Hi, this is a tutorial on introductory dplyr usage. Dplyr is a package for quickly performing all kinds of slicing, dicing, and transforming data sets. It's an indispensable part of my everyday workflow as a data scientist, and in this tutorial, I'm going to demonstrate some of the introductory concepts of dplyr. So let's get started. dplyr is built on the idea of verbs. Verbs are words that describe common data manipulations. So in dplyr, the most basic verbs are these: select, filter, mutate, arrange, group by, summarize. There are some other ones as well that we could add to this list. There's count, there's distinct, there's a few others that we use, but they're somehow less fundamental than those ones because we can kind of get these other ones from the first one. So these are the fundamental ones that we talk about in dplyr. So in this video in particular, I'm going to talk about the common interface between all of these. They're all built on a common programming interface. So if you know how to call one of them, you sort of know how to call all of them, even if you don't know exactly how they work, which is a very convenient thing about this package. And I'm going to go into detail into how we can use select and filter in particular. And we'll also talk a little bit about mutate and summarize. So to start off, I'm going to load up the tidyverse. If you don't have this installed, you should install it. It installs a bunch of packages that all work together, and when you load it, it loads all of those packages all together. So dplyr is one of them. It also loads up ggplot2. It loads up tibble. We're going to see all of these at one point or another. So dplyr is loaded into the namespace now, which is great. And I want to start off by just trying to do some work on the data set called Star Wars, which comes with the dplyr package. So it's loaded into the namespace since we loaded this tidyverse. And so we have Star Wars here. And Star Wars is a type of data set called a tibble, which is also another part of the tidyverse. I won't get too deep into what tibbles are right now, but one of the most sort of obvious differences is that they print a lot nicer than your run-of-the-mill data frames in R. So data frames that you're used to, like another built-in one is Iris. If you look at how this prints out, it prints in quite an ugly way. All of the rows end up printing out. That can be very inconvenient behavior. Tibbles are sort of just a little bit more nicely behaved, especially for larger data sets. And so this is a tibble, but it's mostly just the same as using a data frame. And so the first verb I want to talk about here is filter. Filter is a common data operation, and the idea is we just want to select certain rows based on some criterion. So let's start out. Let's just say that we want to select all the rows where the home world is Tatooine and the species is droid. So using classical R, the way that we would do that probably is we would go Star Wars, bracket, and we would go Star Wars, species equals droid, and Star Wars, homeworld equals Tatooine, and put a comma, and then these are the rows, and then these are the columns. And we get kind of weird output here, and the reason we get weird output is because actually one of these has NAs. So I think what we also need to do is say, and Star Wars homeworld, and we want this not to be NA, so not NA, Star Wars homeworld. And I think that this will give us what we're looking for. There it is. So this is fine. We can do this, and this is how I used R for a really long time. But filter, the filter verb from dplyr makes this code a lot prettier. So let's have a look at how we would do this with filter. So like all the dplyr verbs, filter takes, so we can have a look at the signature of it here. It takes data and then it takes these ... dots, which is a common trope in these dplyr functions. Data is the first argument, and that's going to be our data frame. So the data frame that we're trying to filter is Star Wars, and then we can put as many conditions afterwards as we want, separated by commas, and it will filter it'll give us back the data frame with all of those, where all of those conditions are true. So we can go species equals droid and comma homeworld equals Tatooine and run this, and this gives us obviously the same output. One thing to notice is we didn't actually have to specify that for it to take out the NAs on homeworld. It sort of figures that out on its own. That's good. It's smart. And so we can put whatever type of logical predicate you can think of, we could put in there. So we could also go say filter Star Wars, let's see, mass less than, I don't know, 20. So what are some very small Star Wars characters? We get Yoda and rats. Oh, I don't even know what this one is. You know, whatever else can be true or false, we can put in here, and we can combine it with other ones like this. If we want to put or in there, you just use the pipe just like you do anywhere else. So if we want mass less than 20 or height less than 50, this will be maybe a longer list. Oh, it's the same list. But this is how we would do or. All right, so this is not actually how I usually use filter. What I usually do is use Magrittr in conjunction with filter. And so the way that we would do that is to go Star Wars pipe, which is Control-Shift-M. I did a whole video about Magrittr. I'll link to that below. But Star Wars pipe filter. And let's go back to the droids from Tatooine. So species equals droid homeworld. And a nice thing is too, it'll autocomplete the column names for you. RStudio will do that when it sees that it's in one of these dplyr pipe blocks. So that's really nice behavior. Homeworld equals Tatooine. And we run that and we get the same thing. So the reason that I like to do it this way is because we're going to see that it's quite useful to be able to write these blocks of code where we've got multiple pipes going on and multiple dplyr verbs happening all at the same time. So that's a nice segue for us to talk about how do we use the select verb. So select, Star Wars, let's just use it. Select is for selecting columns. So select, and so what we can do here is select columns by name. So suppose we've got this Star Wars data set. Suppose we didn't want all these columns. We just want, say, the name, the homeworld, and the species. We could go name, homeworld, species, and that would give us just the data set with those 3 columns. So we can put whatever column names we wanted here. And note that it's the same interface as with filter. So the first argument for select is actually the data set, but we use the pipe to put that data set in as the first argument. So these blocks will usually start with data set, pipe, and then a verb. And the nice thing that we can do here is we can combine the verbs together. So we can say, okay, give me filter species equals droid, comma, homeworld equals Tatooine, and then pipe that into the selection, and then we get, whoops, should have done the autocomplete, homeworld equals Tatooine, pipe that into the selection, and then we just get this little subsection of the data frame. So doing this filter and select combination using this kind of older style R syntax it would make for quite a difficult line of code to read. Whereas here, it's quite clear exactly what it is that we're doing. We're filtering based on these predicates, and then we are selecting these 3 columns. The select verb also gives quite a lot of flexibility with respect to how you can select things. So the most common type of selection that you might do might just be by name, so select name, homeworld, species, that type of thing. You can also go sort of anti-selecting by going Star Wars, and let's just have a look at it again. So let's say I don't like these 3 because they look kind of weird. Maybe we'll talk about what those are in another video, but I don't like these 3 columns. So what I can do is I can go Star Wars, select, and you can use the minus sign to specify columns that you don't want. So I don't want films, I don't want vehicles, and I don't want starships. And so that'll select those out of there. And if I want to save this data frame the way that it is, I can go Star Wars equals this, and now Star Wars no longer has those columns. We can also do selection on. There are a few other ways to do it. So one of the nice things we can do is we can go Star Wars select, and you can select based on whether the column name contains a certain substring. So this can be very, very useful. The function that you use inside of the select statement or function, the function that you use contains. And so suppose we just want all the color columns. We can go contains color, and that'll just give us the ones where color is in the column name, which that can be very useful. And you can pair this up with the other selection methods as well. So maybe we want a data frame that has the name, the home world, and the colors, and it'll do that for us. So this is actually packing quite a lot of power and expressiveness into this one little selection statement. So this is very useful. And then we can put this together with filtering. So let's say, okay, this is great, and now I want to filter, and I want, let's say, the home world to be in Tatooine, or Naboo, and this will just give me the ones where this is satisfied. So where homeworld is in Tatooine and Naboo. So this is, already you can get a lot done with this. You can do a lot of slicing and dicing that you might want to do on data sets using these 2 verbs in conjunction with the pipe. But usually what we're aiming for at the end, sometimes what we're aiming for at the end is to be able to say something about the data frame. So one of the most useful verbs for that is the summarise verb. And so I'm going to show an example of how we can put together select, filter, and summarize into something quite useful. So let's have a look at the data set again. And let's ask a question about it. So my question is, what are the average height and weight of female Star Wars characters? And so in order to answer this, you can go Star Wars, and we're only interested in the female characters. So let's start with that. So filter. We want to filter out where gender equals female. And if we just run this, then we get that. So there's 19 of them. And we're also just interested in the height and the mass. So maybe we just want to have a look at those. Select height, mass. And now what we're interested in is what are the averages of these rows, or of these columns rather. So this is where summarise comes in. And so what summarise does is it applies a aggregation function to an entire column. And in this case, the function that we want to apply is the mean. And so it's pretty straightforward to apply. We can go mean height, and let's just start with the height, and then we'll add the weight after. And if we just run this, we'll be a little disappointed. We get NA here. That's because the column contains NAs. So what we need to do is set na.rm equal true, and this tells R that we want to remove the NAs before we compute this mean, and we get this mean here as well. Now, one thing that it will do is name. So this is a tibble again, but it's a tibble with one entry. But it'll name the column the call, which can be not what you want. Luckily, it lets you rename the column by passing a named argument here. So you can go mean height equals, and that will give you something a little bit nicer. And you can do this a few different times. So you can go mean weight equals mean mass na.rm equals true, and that will give me that as well. And any function that we can apply to a vector which returns a single number, we can plug into the summarise verb. So, you know, maybe we're interested in the standard deviation of height. We can go st height equals st, I think it's st and r, right? Yeah, that's okay. St height and na.rm equals true again. By the way, t and true are synonyms in R. We can just use true, t for that, and it'll give me this this summary as well. So all kinds of summaries that we can apply to data sets using the summarize function. Pretty much any function that you can run on a vector, you can put into summarise. And so even just using these three, using the filter, select, and summarize, you can get some really sophisticated analysis done very quickly. And a nice thing with these blocks is a lot of the time you can just sort of copy them, paste it, and you might just have to change one or two things in order to obtain like an answer to another question. So say now we're interested in the male one, so we change this. Now we get the mean height for males, which is, you know, higher than for females and higher than for females, and also the standard deviation is higher, so you can see that it's more volatile. Now, a lot of the time what we are interested in doing is actually doing these two steps all at once so that we could get, okay, so for females it's this, for males it's this, and to do that you use group by, and I'll show that in a future video. But for now, this is the end of the tutorial, so you should be well on your way to being able to slice and dice data with dplyr to your heart's content. Thanks for watching this tutorial, and I hope you'll watch my next one. Bye-bye.